All right, we're heading into the final turn. So this last part of the course is going to talk about how to create a graphical user interface. Everything we've been doing so far has been on the command line or the console or whatever you want to call it. And again, back in the day, that was all that you had. Essentially until Apple came out with their Mac, which they had kind of all but stolen from Xerox's Park Place, which, you know, in this business, stealing is good, or at least whether it's good or not, it happens. Anyway, regardless of that, there are two pieces to having an effective graphical user interface. You know, obviously the benefits are that that's what we're used to these days, for the most part. And a well-designed graphical user interface creates a user experience that enables them to get the job done, whatever that is. You know, so if you're writing a document and you have a good word processor where you don't have to keep fighting it, then it is a useful tool that helps you get the job done. Those of you who've used Microsoft Word know that for some things that works great, and for other things you have to fight it. So, and if you've ever felt like bang your head on the keyboard when you're trying to get a Word document to do what you want, then that's a user interface failure in a way, because it's not doing what you want. Even though you're telling it exactly what you want. Remember the dictum that all of these and applications, programming languages, computers are so stupid that they do what you tell them to and not what you want them to. The problem comes in when you're telling them to do something and they don't do it, then that's where the problem is. The reason, I think, why didn't we start with this? If you notice in the book, kind of fairly early on, they had little sections in the back that were about Java FX, which was a little unfortunate because before a certain period of time, that seemed to be the thing that was coming up, this Java FX thing, if you've taken a look at what they have. And it's a very nice approach, and in some ways fixes some things that Swing was not so good at, just as Swing fixed some things that the abstract windowing toolkit was not so great about. But for whatever reason, Oracle took Java FX out of the Java distribution, which kind of sends a message. Okay, so Swing is still in there. And that's what we're going to talk about. So you say, well, why didn't we start with this? Well, because for any computer application, the most important thing is what it does, not the user interface. Not that the user interface isn't important, but if you have the best user interface in the world, but it doesn't get the job done behind the scenes, then you just have a pretty little hobby toy. Now, on the other hand, if you have an application which does a really good job of getting the job done, but doesn't have an effective user experience, then that's a failure just as well. And if you've ever struggled with a website or an application that just kind of seems to put up roadblocks every time you try to get things done, then you kind of have a sense of that. And if you've used computers or applications for any length of time, then you have experienced that. And if you haven't experienced that, then you haven't been using computers enough. These things exist. So the point is that none of this happens without an explicit intent and implementation by some programmer somewhere. Everything that you experience, whether it's in the operating system or in an application, is something that somebody wrote some code somewhere for. And I was having discussion with somebody about, well, is writing code going to become obsolete at some point? Well, they've been saying that literally for decades, and it's still here. Now, there are a lot of things where writing code has been kind of overcome by some helpers, and you see that in NetBeans. When Java first came out, there weren't any Java IDEs, integrated development environments, as we've been using. The IDE that I used was Notepad and the command line. All right. Now that worked, but it didn't have so many of the things that I think you're probably used to with NetBeans. So, for example, if you declare an object variable and you want to invoke a method, then in NetBeans you type dot and then it gives you some prompts so that instead of trying to fat finger it, you can just sort of select it. In fact, you can see what the different possibilities are. That didn't exist. And that exists because the people who wrote NetBeans made it exist. That didn't just happen. That's not a law of nature. So everything that happens, and the ability to do that and keep your program live, you may have noticed that when that thing kind of pops up, you still can manipulate NetBeans. Whereas if you go to start a new project, say, while that new project dialog is up, NetBeans is locked. Again, we will talk about kind of what that's about. And again, that's something that you want to do. In other words, when you're creating a new project, you don't want other stuff to be going on. But that's a design decision. That's something that the people who wrote it decided to do. So the reason why we focus so much on what's happening behind the scenes is that's what the application is going to do. That doesn't mean that having a good user interface isn't important. And I think that for the most part, NetBeans is a pretty good user interface. Again, I have some quibbles with it, but I have quibbles with everything, and you probably do too. But okay, so now we're going to spend a little bit of time just talking about what some of the possibilities are for presenting the Java's Swing graphical user interface widgets. Widgets are kind of the things that you manipulate. Everything that you see in an application is a widget. Is just what they call it. Some people call it. I don't know. Maybe it's an old term. Okay. So today we're going to focus on three. One which is not a widget. The one thing that's not a widget is something called a JFrame, and what the JFrame is the window where you put everything. So. And since you're all experienced computer users, you're used to some of these various widgets. We're going to just look at two of them today, and then we're going to look at some more next week. We will not look at all of the different possibilities, because we could probably spend the whole quarter just on that. But after kind of talking about what some of the things you can do to manipulate stuff and start a program off, then we're going to connect that with what we've done previously, and that's why introducing threads was important, because typically if we're going to be doing something which takes a little while, we want to do it in a different thread than the graphics thread. So we're going to look at JFrame, JLabels, and JButtons today. So what's a JFrame? That's the window for all Swing applications. And you can have more than one. Typically, there's just one, typically, but you can have as many as you want. Now, the JFrame is actually just a ridiculously complicated class. It's got a ton of things. There are all kinds of fancy stuff you can do with it, but what we're going to focus in is actually a piece of it called the content pane. And the content pane is well, we're not going to actually explore anything else in JFrame besides that. But the content pane is where all of our widgets are going to go. And what we'll show is that Swing has, and actually, Java kind of introduced this with their original user interface or framework called the Abstract Windowing Toolkit, or AWT, which left a lot to be desired. So I think we like to call it the awful windowing toolkit. But it has one of the nice things that Java introduced was the idea of these layout managers. We're going to look at a couple of them today. And each component or container, as it were, has a default one that can always be overridden. We'll show you how to override that as well. The one that the content pane has is something called a border layout, and we'll see what that looks like. Basically, what that looks like is something like this, is that it divides the window, or at least the content pane, up into 5 sections. And each has sort of a different kind of rule for how it gets laid out. They're called north, south, east and west, and center. And the way they work is that starting with the center tries to expand as big as it can until it hits something that it can't. The east and west try to expand inward as far as it can until it hits something that it can't, and then usually it pushes back against the center, and likewise the north and south try to push down, except when they're pushed back by something else like the center. Okay, so now, if you've been using computers at all lately, you know that one of the ways to close a window is through clicking on the X, which if you're in Windows is in the upper right, and if you're on a Mac is like a red dot on the upper left. Same thing, why are they different? Because either Apple said, well, Windows puts it on the right, so we're going to put it on the left, or Windows said, Mac puts it on the left, so we're going to put it on the right. The thing is that when you do something like that, then it causes something to happen. There's a default behavior, and then there's a behavior that you can override. The default behavior when closing a JFrame instance is to simply make it vanish and do nothing else. Meaning, do nothing means that the program keeps running. In a way, now, as you've seen with threads, you've seen that you can kind of execute code and kind of reach the end of, say, the main method, and the program keeps running because these threads are going. That's what's going on here. So the graphics thread is still running, even though it's not displaying anything. Okay, so, and knowing how threads work now, you should hopefully have that mental model. Now, for user friendliness, that's actually a good thing, except that, picture this, you're editing a Word document, you sort of sit there and you've typed all the most brilliant thing that you've done and in your thesis, for maybe an hour or two, and then you accidentally hit the red X. Or have you ever been editing something and you accidentally try to close it? Now, what does the application do? Yeah, are you sure? They didn't always do that. Okay. Now, so basically what it does is that means that window, and again, on Windows, or if it's in some other language, then the exact mechanism is slightly different, but it's still doing the same thing. In other words, it's not doing anything yet. It's saying, okay, you want me to close, but are you really, really sure? And that, again, that doesn't happen by accident. That happens because some programmer put that in. Okay, we'll see how to do that. However, in order to implement that, we're going to need to understand about modal dialogues and how certain events are trapped and responded to. So we haven't done that yet. So for the ease of the examples that we're going to do, the other option is that we're going to exit when we close. So this is the user unfriendly, the user hostile thing. In other words, when we hit the red X, then it's just going to close the whole program down. But that's only useful for examples, you know. So for if you're writing an application, then you want to make sure that you check with the user if there's something that needs to be saved. That's obviously an important thing. And if you've ever accidentally tried to close a window, then and run the risk of losing stuff. Then okay, so two widgets. We're going to look at Jlabel. Okay, so what is a Jlabel? A label is just simply some text that you display. So this is the if you want to just give some text that you want the user to read but can't do anything with it, then use a Jlabel. So it's for displaying text. It's not editable by the user, although it is editable programmatically. We'll see some examples of that. In other words, the program can change the text in the label, but the user can't. Further, we can put an image in. We're not going to worry about that. That's to me a little bit. That's something that you can do. You can put image and text, or just an image. And we can customize things like the font, and the background color, and all kinds of other things, which we'll do a little bit of just to illustrate, but not a whole lot. Again, okay, JButton. Now what's a button? Well, you all know what a button is. You know, not these things. The things that you click on. When you click on a button, you expect something to happen. And the thing to keep in mind is that logically, a menu item is like a button. Okay, so what is a button in terms of user interface? It's something where you click on and something happens. So if just like a regular button, like a save button or something like that, then that's something that you're all used to. But a menu, think of a menu, like if I say file, open, whatever, again, when I say open or whatever, that's just like a button. So logically, a menu item is like a button as well. And a toolbar is also like a button, you know, even though it responds a little bit differently. Now the thing is that, and as we'll see, we can create buttons, we can put them in, they will look like, they will respond to the user click. So you click on it and you expect it to kind of have a little depression as if you were clicking a physical button. But by itself, it doesn't do anything. There are a number of different ways of making the button do something. The most effective, in my opinion, and the most general is something called an action listener. And time permitting, we'll see an example of that. In other words, clicking on the button and having what it do are two different operations. And the thing is, if you make those too close together, if you kind of weld what the button does to the button itself, then that's not a very effective design. And unfortunately, if you read about ways that this is suggested, they will use something called an anonymous inner class to respond to the button. And that is a terrible design. So we're not going to do that. We are going to use one anonymous inner class, though. Again, in 99.9% of the time, anonymous inner classes are evil. There's one small case where it isn't, and we'll see that. Okay, so mentioned layout managers. The border layout is one we'll take a look at and kind of showed roughly. Two of the other ones, there's one called as we'll see, because of the behavior of the pieces in the border layout, what that will tend to do is that will tend to make your widgets be as big as possible, and sometimes that's bigger than what you want. What the flow layout does, and we'll see an example of this, is what that does is that takes your widgets, whatever they are, and just kind of lays them out in the same row, but then what the flow part is that depending on how big the window is, it'll wrap around. Again, we'll see an example of that. Another layout is something called a grid layout, and there, think like a table or like a spreadsheet or something like that, where you typically will fix the number of columns, the number of rows. You can set the number of rows, but it'll keep adding stuff until as long as it can. And again, there in the grid layout, it will tend to be kind of big. Then the most general one is something called a grid bag layout, and that is really confusing. So we're not going to talk about that other than to validate its existence. But a more useful one is something called a box layout. We'll take a peek at that because that's really, in many respects, the most flexible. And because sort of why kind of fuss about this? Well, as the one writing this, as the one designing how you want your application to look, then these are different ways that you can put the items in your graphical interface. Now, the one piece that we're not going to talk about until next class is that there's kind of a Russian nested doll approach here, where there are things called containers where you can put other things in, and you can put containers inside of other containers and all that. So in other words, there's pretty much unlimited ways that you can display things. And then finally, okay, so how do we run this thing? Well, we instantiate a J-frame, or typically a subclass of the J-frame. That's what we're going to be doing. We add the component. If we want to make it do something, we want to connect the components to the listeners. We'll see a simple example of that. And then here's the thing, is that for simple examples, we can kind of get away with some shenanigans, as it were. But we want to make sure that the J-frame goes on the graphics queue. And the way to do that is by a static method of something called the event queue, which is basically the graphics thread. And we say invoke later, and then that puts it on the graphics thread.